EKS, yeah, EKS installation. So we'll show you. So EKS installation, guys. So for this, I already pinged in the chat, right? The cluster configuration. Did you guys watch that one? Guys, in the Google Hub, so you guys can also watch this recording. This is a public one. So for creating the EKS management host on AWS. Okay. Yeah. So how to create the EKS management host in AWS? So launch a new Ubuntu VM using the EC2 micro T2 micro for the registration. I already showed you, right, guys? Further and connect to the machine and install the Kubernetes using the below commands. So this is nothing but a remote mission, guys. So once we install this remote mission, then you can install the EKS using the below commands. You can directly install the EKS by using this command, guys. Okay. So then, so what you guys can do, create a IAM role and attach EKS management host. We need to create the IAM role and attach to EKS management host, create a new IAM service, adding below permission to this role. We need a IAM full access, VPC full access, EC2 full access, so cloud formation full access, administrator full access. So we need to provide these guys for the role. Something like enter the role names like EKS role EC2. So attach the role to EKS management host, then click the security, modify IAM role, attach IAM role to role we have created. So create a EKS cluster. How you can create the EKS cluster? By using EKS CTL, create cluster, name cluster, region, and node type of the instance. So nodes and zones, which zone you want to create, guys. For example, if you want to create a case cluster in the North Virginia region, you can connect this, you can use this North Virginia, or else you want to create a case cluster in your Mumbai region, South AP South one. You guys use this command, guys. Okay. So cluster creation will take 5 to 10 minutes of your time. So we have to wait. After the cluster created, we can check nodes using the below commands. So kubectl get nodes. So we should able to see the EKS cluster nodes here. Okay. So we are done with the setup of our we are done with our setup. Then after you practice delete the cluster and resources we have used in the AWS to avoid the billing. Guys, so EKS cluster definitely will get the charge. If, the bill account will generate. So what you guys can do is you can go to the AWS support and you will send a mail. I will show you guys how to send a mail. So they will wipe off the so you select as a student. I'm as a student. I'm practicing the EKS. You guys can provide the support. The send a mail to the support. They will wipe off the amount, guys. Guys, understood, right? So first, so where is that? First, we need to create the IAM role, guys. I already showed you guys, right, last time. One second. Yeah, guys. So first we need to create the IAM role. So we need to create the IAM role. And so this is the remote mission. This is not a cluster, EKS cluster. The EKS EC2 mission, first you need to create the IAM role, then install the kubectl and EKS CTL. Then we can create the AWS EKS. Okay. So Kubernetes architecture you already knows, right, guys? Yeah. So it's recommended to run the command in the master node. Something like this is the remote node, this is the master node, these are the worker nodes. This automatically created, guys, EKS. So we are installing the remote mission and install the kubectl, EKS EKS. So what is that? EKS AWS CLI and kubectl, guys. Kubectl and IAM. First we will create the IAM, guys. We'll create the IAM. Yeah, guys, I logged into the my console. Elastic Kubernetes cluster, right? This is the EKS, guys. So EKS is nothing but a, so we have a two types of, so to do two types of Kubernetes, right? Self-managed Kubernetes cluster and provider managed Kubernetes cluster. So provider manager Kubernetes cluster means, so we don't worry, we don't need to create our own. So the providers will create it and they can manage. You just use it and you just use it, right? That is nothing but a provider managed Kubernetes cluster. So self-managed Kubernetes cluster means we need to create and we need to manage our own. That is nothing but a self-managed Kubernetes cluster. KubeADM, so right, Minikube. These all are the self-managed Kubernetes cluster. The provider managed Kubernetes clusters are EKS, AKS, GKE, OKE, right, guys? IKE, right? So these all are the provider managed Kubernetes cluster. So now we are creating the EKS, Elastic Elastic Kubernetes service. So we are creating the Elastic Kubernetes service, guys. Guys, understood? So for this purpose, first we need to create a remote mission. Remote mission. So before remote mission, so we need to create the IAM rule. IAM role, and we can assign it to that remote mission. Okay. So first we will create a IAM role. So IAM, click to the IAM. Yeah, first we will go to the roles, create a role, right? Next, what is this, guys? We can choose it for the commonly used service. EC2.
EC.
Next. Yeah, what is that, guys? Administrator. administrator access, IAM full access, IAM full access, EC2 full access, then VPC full access, VPC full access, IAM full access, IAM full access, VPC full access, EC2 full access, cloud formation full access. So cloud formation full access, EC2 full access, right, guys. Next, yeah. So administrator full access, Amazon EC2 full access, Amazon VPC full access, AWS cloud formation full access, and IAM full access, guys. Okay. The role name. So what is called, guys? The role name is. So enter the role name. Enter the role name. What is that role name, guys? EKS role EC2. For example, you can take the EKS role, EKS role EC2, EKS role EC2. Then, yeah, create a role. So what is that, guys? EC2 role, EKS role EC2. So this is the role we created, guys. Okay. So the next, you can create the EC2 instance. Go to the EC2 instance. Okay. So create a launch instance. So what you guys can do is EKS remote mission. So EKS remote mission. What we took, guys, you guys can took Amazon, not Amazon. You guys can take the Ubuntu 22.04. Select Twitter micro is enough, guys. This is a remote mission, right? No need. So then let's select the key pair. Proceed with it. Key pair. Create a key pair. EKS PPK create. Yeah, EKS. Okay. Key pair EKS. Select existing security group, guys. No need to create anything. Just launch instance. Yeah, guys. Instance is launched. Guys, instance is launched. So meanwhile, you guys select, yeah, create a ARM role attached to the EKS management host. Create a new role using the AM service. Yeah. So select use case EC2. So add below permission to the role. Yeah, we did. And then enter the role name and attach it to the created role to the EKS management host. So select EC2, click on security, modify AM role, attach AM role to we have created. Okay. So then once it is completed, so create a EKS management host in AWS. So we are launched the EC2 instance and connect to the mission and install these commands. Okay, once we install these commands, so that we already created the AM role, right? Then second, so we will install AWS CLI and kubectl and EKS ETL. Okay. So once we install this, connect public DNS T, right? We can take the putty, putty, SSH, auth, credentials, browse, EKS, select, open. Why still it is showing pending? Yeah, so still it is pending, right? It is creating. That's the reason we are getting this error. Let's try it on. Terminate the instance. I'm terminating, guys. Refresh. Shutting down. Okay, no worries. So I want to create it in the Mumbai region, guys, because of it's near to our India, right? So I'm trying to create this on the launch instance, web server, EKS remote, EKS remote, browse it. So what is that, guys? Ubuntu. You guys can take the yeah. So guys, Ubuntu 22.02, volume SSD. Free tier eligible, guys. This is free tier eligible. Selecting this, right? T2 micro key pair. We already created a create a key pair. Remote EKS pub key. Okay. Network I'm using as it is. Launch instance. So IAM is global, right? You already knows, guys. So IAM is a global. You see, guys, when you check the IAM, it is showing something like a global. So the instances is the region based, but the IAM is a global. So EC2 Mumbai region instances. Yeah, it's running. It's running, right? Now took the public DNS and duplicate session. Sorry, new session. So we'll provide the host, then auth credentials, private, remote EKS, open, accept. Yeah. What is that, guys? For Ubuntu is the user. Yes. I want to change the settings of the appearance. Change settings. Bold 18. Okay. Apply. Yeah, guys. So Ubuntu. So Ubuntu. So we install the remote machine. So we install the remote machine. So then what you can do? So launch the new Ubuntu machine. Then connect to the machine and install the kubectl command on the below commands. So before that, one second, guys. Okay, guys. So we can attach the attached created to EKS role, right? So we will do it, guys.
Sir,
Hello? Yes. Guys are able to hear? Hello?
sir,
Yeah. For creating this, guys, we understood, right? So create a EKS cluster using. So you need to create the EKS cluster. EKS cluster, EKS create cluster, name cluster name, hyphen region equal to region name, hyphen node type equal to instance type, hyphen node min equal to 2, max equal to 2, zones, guys. So here create a cluster, EKS create a cluster, hyphen name equal to RE8. This is the cluster name, guys. So this is the cluster name, hyphen region equal to AP South 1. I'm trying to create the EKS cluster in the EP South 1 region, hyphen node type equal to T2 medium, guys. So T2 medium and hyphen zone equal to AP South 1A, AP South 1B. So here nodes minimum, nodes maximum. By default, it is taking 2, guys. So no need to provide the nodes. No need to provide the nodes. So as of now, so we are done with the EKS management host to AWS. Then created a ARM role and attached the management host and create a EKS cluster using the EKS CTL. So this is the command, guys. This is the command. So create cluster creation will take 5 to 10 minutes time. So after cluster created, we can check the nodes using the below command kubectl get nodes. In the remote mission, you can check kubectl get nodes. You will see, guys. You will see the nodes, how many nodes are created. Okay. So after running your mission, you guys, what you guys can do, eclipse delete cluster. I'm an name hyphen. So you can use the name, guys. Okay. So it will take 5 to 10 minutes. Meanwhile, you can see it in the EKS, guys. Go to EKS Kubernetes Service. Is it creating or not? Yeah, guys. You see? So Hari IT cluster 4 is creating. Hari IT cluster 4 is creating. What is the Kubernetes version, guys? 1.30. So what is the Kubernetes version? So 1.30 Kubernetes version is creating. So before what we done, guys, before what we done, so we created a EC2 instances and we installed the Kubernetes cluster. So that is nothing but a self-managed Kubernetes cluster. So now we are trying to create a provider managed Kubernetes cluster. So that is a EKS. What is that, guys? Provider managed Kubernetes cluster. Yeah, guys. So Elastic Kubernetes Service, Amazon EKS, fully managed Kubernetes control plane. Amazon EKS is a managed service that makes it easy for you to use Kubernetes on AWS without needing to install and operate your own Kubernetes control plane. Right? Control a plane. So how it works, provision an EKS cluster, and then deploy worker nodes and add worker nodes to the your EKS cluster. So connect to EKS, point your favorite Kubernetes tooling at your EKS cluster, how you can connect your EKS cluster. So run the Kubernetes app and deploy your Kubernetes application to your EKS cluster. So Amazon EKS exposes a Kubernetes API endpoint. Your existing Kubernetes tool can connect it directly to the EKS managed control plane. Worker nodes run as EC2 instance in our account. Okay. So why use Amazon EKS? Hybrid container deployments, application migration, microservice, batch processing. Guys, understood? So if you want, you can use the documentation, API reference, FAQ, EKS forum also. So if you want, guys, you can check it. Okay. Future of Amazon is it. Kubernetes cluster is a managed service that eliminates to need to install, operate, and maintain your own Kubernetes control plan on Amazon Web Services. So Kubernetes is an open source system that automates the management, scaling, and deployment and containerized applications. So we can set up, guys. We can set up pricing also. So Amazon Kubernetes service, welcome. So Amazon EKS auth API to assume role for prod identity servers. Okay. So Amazon Kubernetes cluster. So FAQ is, what is Amazon Kubernetes service cluster? What is Kubernetes? Why should we use Amazon EKS? How does Amazon EKS works? Which operating system does EKS support? I have a feature request. So who do I tell? Integrations. Does Amazon EKS work with my existing Kubernetes application and tools? Does Amazon EKS work with AWS Fargate? What are the Amazon EKS add-ons? Why should I use Amazon EKS add-ons? Versions and updates. So how do you update my worker nodes? What is Amazon EKS extended support? Pricing. So you pay 0.10 per hour for each Amazon EKS cluster. A cluster you create and for the AWS resources you create to run your Kubernetes worker nodes. You only pay for what you use as you use it. There are no minimum fees, no upfront commitments. Find for the more information. So questions tagged with Amazon Elastic services. So validating admission policy support EKS, change the Docker version. Self-managed node groups not joining to EKS cluster. Graduate EKS upgrade, waiting, Postgres Tago, where is root certificate, issue with attaching IAM role, multiple node groups in AWS EKS, cross account, configuring EKS cross account access entries using IAM. So these are the forums, guys. If you want, you guys can use it and yeah, it will take. So waiting for cloud formation stack EKL Hari cluster 4. So it will take 5 to 10 minutes, guys. 228, 227, 233. Yeah, okay, guys. So meanwhile, we will discuss the yeah. So after that, right, guys, how you can connect this control plane node? So by using the kubectl get node. So kubectl get nodes. Yeah, you guys understood, right? Container pod namespace service deployment. We already discussed about the namespace creation pod, kubectl pod. We already discussed how to run our applications in and interactive or declarative mode. So interactive, we already showed declarative mode in the API version kind metadata spec. So managing our API kind metadata, API version represents the version of our API like V1, V2, V3. So kind represents the what is the purpose of this file, manifest file, a deployment file or a pod file. You can use it, guys. So meta represents the data about the data labels. So spec represents the specification, what you want to use for this manifest. A container if you want to create a container or whatever it may be, guys. So for example, Java web app data YAML. So API version V1 kinda pod. So what we are trying to create? We're trying to create a pod. Metadata. So what is metadata? Name equal to, so metadata name equal to Java web app pod. So label app equal to Java web app. Spec, guys. Kinda spec. These are the most important. Spec is nothing but a specification. So what is the specification? What you are trying to create a pod, you are trying to create the pod. Within the pod, we need to create the containers. So spec equal to container. So name equal to Java web app container. So name is a comment, guys. This is the a comment. So image equal to tech world with Tomcat. Whatever you are in the Docker hub, right, or a registry, or a something like artifact or whatever it may be, guys. You can need to provide this. We need to provide the path. So ports container port equal to 88. You are just allowing the container port only, not on the host port. This is just a manifest file, guys. What is that? This is the a manifest file to create the pod. To create the pod inside the worker node. To create the pod inside the worker node. So yeah, so I want to create a pod and I want to create a one node. So create a pod, and within the pod I want to create a container. So which container you want to create? Which image of the you can select the image. So this is we are trying. So how you can try? You can use the kubectl is the command mode in order to perform the operations on the master node. I want to create a this. So what is that command? Guy? Kubectl apply -f. Once you create the kubectl apply, the API server will take the manifest file and yeah. So execute the command by kubectl that will talk to the API server, and API server will act as a mediator between kubectl and the Kubernetes software. So whenever a request comes from the kubectl, that will be taken care by the API server will talk to the underlying Kubernetes software. So whenever a request comes from the API server, and API server stores the information in the HCD. So the kubectl file, right? The file stores in the HCD. It is a data store in the Kubernetes. It will act as a database to store the detail of the Kubernetes cluster. Schedule is going to check that what are the pending tasks are available. What are the pending tasks? We are trying to ask to create a pod. Within the pod, we can ask to create a container, right? So scheduler is going to check that what are the pending tasks are available. Then scheduler is going to assign the task to the controller manager. So controller manager is going to schedule them before going to the schedule. Scheduler will talk to the kubelet. Scheduler will talk to the kubelet. So then kubelet is a worker node agent. What is that, guys? Kubelet is a worker node agent. It is going to check the health of the node. So kubelet is a worker node agent. It is going to check the health of the node. Kubelet will check the resources available in the node. We can check the resources available. Kubelet will make sure pods are running successfully and containers are running successfully. So kubelet will create a container, the worker node, using the pods, the help of the Docker runtime. So Docker runtime is we are using to create a containers. Container is nothing but a runtime of our application. Guys, understood now? By using manifest file, what you are trying to create? You are trying to create a container. So what is the manifest? Manifest file. Yeah, you see, guys. So we can create a pods in two ways. Interactive mode. Interactive approach means using commands we can create the pod. kubectl run -name java web app pod image tech something like tech world with Java. So we can directly create by using the run. Or declarative approach means using the manifest file. So manifest file is nothing but a YAM file. We can create the pod. How you can create the pods, guys? You can create the pods using YAML files. YAML a file. So YAML means Ansible. So we can use Ansible YAML file. There is nothing but a manifest. So meaning of a API kind metadata you understood. So this is the just a manifest file for creating the pod. So this is a creating the pod. So API version v1 kind equal to pod. So metadata name just this is the name of the metadata. Label equal to app. So the spec means specifications. So in kind what you are trying to create, you are trying to create a pod. In the pod, so there are containers. So what is the container name? Java web app container, and the image. So where we can get this? a image, a Docker image. We can get the image Docker image and we can provide the path, then pod. So this is just a API version kind of metadata spec. Guys, understood? This is the manifest file. So this is the a manifest file. Let's check it's created. So waiting for cloud formation stack, AKS node group ng, creating a cluster. Why guys, why is this is taking so much time? EKS, right? EKS, Elastic Kubernetes Service. Yeah, it is an active created, guys. So yeah, Hari IT cluster is created. So this is the overview of the Hari IT cluster. So this is the API server endpoint. Certificate, this is the certificate. So OpenID, this is the OpenID contact provider URL. This is the cluster IAM role. So this is the cluster IAM role. This is the ARN. This is created 16 minutes ago. That platform motion is EKS2, right? The resources. So what are the resources? What are the parts are there? So there is no parts, right? We did not created the part templates, replica sets, deployments, select stateful sets, so daemon sets, so jobs, so cron jobs, so priority classes, horizontal pod, autoscaler, cluster nodes, so nodes, so namespaces, so API server, leases, so runtime classes, so flow schema, so priority level, so service and networking, services, so endpoints, so ingress classes, so the configs and secrets, so storage, so storage guys, persistent volume, so storage classes, so volume attachment, cider drivers, nodes, so capacities, how you can authenticate guys, authorization, cluster role binds, so roles, so role bindings, so policies, so limit ranges, so resource quotas, so network policies, so and extensions. So these all are the attributes, guys, resources. So cluster nodes, still not yet created. So compute. So this is the compute service, guys. So this is the compute service for the node groups. So desired node group, two node groups, guys. So the IAM release version. So this is the template. So this is the template networking. So yeah, these are the subnets created, guys. This is the VPC created cluster group security groups. This is the additional security groups. So add-ons, so I did not access. So I am principal ARN. How you can access this? Observability and upgrades insights, update history. No, there is no history. This is nothing but a EKS cluster attributes, guys. This is nothing but a EKS cluster attributes. Guys, now you understood? Yeah, EKS cluster is that EKS cluster Hari AP South 1 region is ready, guys. Is it ready? Okay. Now you can see, guys, all EKS cluster resources for Hari IT cluster have been created. So created node groups in the cluster Hari. So node group created has two nodes. So node 1 EP South is compute internal is ready. Node 2, this is the node 2, guys. So waiting for at least two nodes to become ready in the node group, guys. So node, so we have these are the two nodes. 37 wait ready. Created one managed node group is a cluster. So kubectl command should work with the home Ubuntu kube config try to get the node. So EKS cluster. So EKS cluster Hari 80 cluster and AP South 1 region is ready. Now you want to copy this. Uh, guys. So let's check is it copied. So what this is, guys? This is a kubeconfig file. Cat. Yeah. So this is the kubeconfig file, guys. What this is? This is a a kube configuration file. Now let's check the kubectl get nodes. Guys, understood? Two nodes are ready. So two nodes are ready. So one is 37, one is 116. kubectl get nodes. kubectl get nodes. Guys, understood? Then kubectl get pods. So get pods. No resources found in the default namespace. No resources so found in the default namespace. Yeah. Now, so we can create a manifest file, guys. So how you can create the manifest file? Yeah, in this location, guys. So if you figure out, yeah, so I already created the manifest file, few of the manifest files, guys. So for example, API version v1, kind equal to pod, metadata equal to nginx, labels equal to nginx, a spec container name equal to nginx, image equal to nginx, port equal to this one, guys. So for example, this is one of the manifest file. I'm creating just creating for the pod, guys. Creating for the pod. This is that Docker Hub created, guys. The Docker Hub is created. Let's create this one. vi nginx.yaml in this in this in this I will show you guys. Just you guys. So first time we will create this, guys. API version. API version. So API version. What is the version, guys? v1. Okay. API version equal to so v1. Next kind. So kind also same from here. Okay, and kind colon. What is that we are trying to create? Pod, guys. So pod. So we are trying to create a pod. Next metadata. What is that, guys? Metadata. So metadata is a data about the data. Just name. You can provide the name, call it as a so metadata nginx. nginx. We are taking from the labels. Labels, guys. So labels, what is the label? Labels app labels app app labels app name equal to nginx nginx. Next spec, guys. Spec you can create from the metadata. Spec is nothing but a specifications, guys. So what are the specifications? Specification is a container. What you are trying to create? Containers. What are the, guys? Containers. In the containers, we need to provide the name, guys. So hyphen name equal to nginx. Then image equal to, so it is getting from the nginx nginx colon 1.14.2. For example, I'm taking the version of 1.14.2. Next, guys, port. What are that? Ports. So ports. So I want to create a container port, guys. What is that? Container port. Container port equal to 80. So container port equal to 80. Guys, understood? API version, A small, V capital, API version V1, kind, P caps, pod, metadata, name, labels, app spec, containers, image, so image, ports, container port, P is capital, guys. Guys, this is a manifest file. So how you can create a manifest file? You need a API version, kind, metadata, spec. These are the four important topics if you want to create a manifest file. Guys, understood? API version, kind, metadata, spec, containers. So in the specifications, spec is nothing but a specifications. The specification you are providing the image and ports. Image and port. Yes, guys. So created the a manifest file. What is the manifest file, guys? So this is the manifest file for so kind. So what is the purpose of this manifest file? For creating the pod. What is that, guys? So what is the purpose of this manifest file? To creating the pod. So so how you can create our pods and containers in the Kubernetes? Through the manifest file only. So we can create either in interactive mode or a declarative mode. So declarative mode. So we are creating the we are creating the manifest file. We are creating the pod and containers in the through the manifest file. Through the manifest file. Guys, understood? Create a pod using the manifest file. How you can create the pod using the manifest file? You can use the kubectl. Kubectl is the command. Kubectl apply. So kubectl apply -f means f means the manifest file. So where is the manifest file? So this is the manifest file I'm trying to apply. Yeah, pod nginx is created. Pod nginx is created. So before we use the get pods, it is showing no resources found in the default namespace. Now you can check kubectl get pods. Get pods. You see, one pod is running. Nginx pod is running. The age is 19 seconds. So how many restarts? 0 restarts. Status is running. Now, so we can check so describe the pod using the below command. What is the command, guys? kubectl describe. kubectl describe pod. Describe means we will get the information. ng nginx nginx it will describe, guys. Yeah, so we need to know, right? So we have a two worker nodes are running. We don't know where the prod is created. So where the prod is created? Yeah, so how many worker nodes created? 37 and 116. Let's see in where the pod is created. Where the prod is created. Something like a describe pod name equal to nginx namespace equal to default, because of we are not creating any namespace. So priority 0, node is equal to 116. What is that, guys? AP South 116. The node where it created, guys. So it created the container in the this node. The pod is created under the 116 node. 116 node, right? The ip of the ip of the pod, the ip of the pod is 192.168.48.102. The pod ip address labels, guys. So label equal to app nginx, app equal to nginx label. So IP address is 192.168.48.101. So container, this is the container ID. So image equal to this one. So Docker image ID, it is getting from the Docker IO libraries from getting this, the path. Port equal to 80, host port 0, state running, started Friday 14th June 252. So ready, true. Restart count 0, environment none, mounts var run secrets Kubernetes service account from kube API access data. So this is conditions, type status true, everything pod ready to start, container initialized ready, container ready, pod scheduled, so volume, so guys, so schedule 52 default scheduler successfully assigned the default namespace nginx from this, pulling the image from here, successfully pulled the image and created the container nginx, started the container nginx. Guys, understood? Created the container nginx and started the container nginx. So check where the pod is running. So where the describe the pod and where the pod is running. You can check it kubectl get pods kubectl get pods -o wide. Yeah. So kubectl get pods, it shows only just running. Yeah, just it is running or not. If you use the -o wide, you can see the entire information. So the IP address and it is running from this node. It is running from this node. Yes, understood? So we can access the pod across the cluster using the pod IP. Call pod IP. Let's check, guys. CURL call. What is the IP of the pod? So IP of the pod is, this is the IP of the pod. Then colon 80. Why, guys, the call is control C sudo apt install call. Yeah, call it already installed, right? Call pod IP http :// 192.168:80. I think not allowed. Let's check, guys. Yeah. Open all the traffic from the public service IP range 10.0.0. Okay, so it will not access the pod IP in the 1 second, guys. Yeah, we can use this in the HTTP in the outside, guys. Outside it will not access. Inside it will access, but I don't know why it is not showing. Just 80, right? We will give the 80. Yeah, it is showing something like so we cannot access. So we can access the pod using uh, using in the local we can access it. So local we can access it, but so in the outer side we cannot access. But the outer side, so we cannot access. Yeah. So pod commands: get all pods, kubectl get pods, create a pod using the manifest file, kubectl apply -i, something like nginx.yaml. So describe the pod using the below command. This is the describe. Check where the pod is running. Kubectl get pods -i word. So we can access the pod across the cluster using the pod IP. So across the cluster we can access, but we cannot access the pod using pod IP outside of the cluster. So outside of the cluster, we need outside, right? Because of we just created the pod, and within the container, we need to access in the outside of the card. So make a request to the API server using the manifest file to create a pod. Yes, make a request. So kubectl API server will save the pod info in the HCD. Yes, scheduler find the unscheduled pod in info and scheduler that pod for the execution in the node. Kubelet will see the pod execution schedule and it will trigger the Docker runtime. Docker runtime will run the container inside the pod. So pod is imperial, lives for a short period of time, right, guys? So pod is a imperial, it lives a short period of time. So when pod is recreated, then the pod IP will change, guys. If the So it is not recommended to access the pod IP, pod using the pod IP, pod ID or pod IP. So pod IP, right guys? So let's check. So we want to, so what is the container guys? kubectl get pods. So this is the pod, right? So nginx, something like nginx. So age equal to docker images sudo snap install version sudo snap install docker podman docker install docker info docker guys. kubectl delete pod nginx. Yeah, you see guys, kubectl get pods. Is there any pods is created? Yeah. So the IP is, so something like so what is the IP address of this server? This IP address of this server is something like a pod IP address is 192.168.48.108. Let's try to apply the manifest file guys. Let's check. So which pod is, yeah, pod is created. Something like IP kubectl get pods running, get pods -o wide. Yeah guys, you see 108 is created, 108 is created, but we cannot create the same IP address. So case is I think different. So yeah, so it will create, it will so if you delete the, it will not create the another pod IP. So the container different pod IPs, right? So that's the reason. So we are not using the pod IP. So if you recreate it, the pod IP will change it. It will not recommended to access the pod IP using the pod using the pod IP. So what is that guys? So service. So we will use the Kubernetes service component to execute the pods. So Kubernetes service will make pods accessible, discoverable inside the cluster and outside the cluster also. What is that guys? So we will use the Kubernetes service component. We will use the Kubernetes service component to execute the pods. Kubernetes service will make the pods accessible, discoverable inside the cluster and outside the cluster also. So when we can create a service, we will get one virtual IP address. So one virtual IP address, cluster IP will be registered in the Kubernetes DNS with its name. So service is responsible to make our pods discoverable, accessible inside and outside the cluster. So that's the reason we are using the services. So service will identify the pods using the pods label and selectors. So service will identify by using the pod using the pod label, right? Label and selectors. So we have a three types of services: cluster IP, node port to load balancer. So cluster IP, node port to load balancer. So service concept, something like this is the a pod manifest file. So API version v1, kind equal to pod, metadata, name equal to Java web, labels equal to this is spec container, name, image equal to something like this is the mine image, so ports container. So this is the pod manifest file. So what is the service manifest file? So in the service manifest file, we need to provide the type, service type, so and the selector. So type under selector. So what is the type of the service? Cluster IP selector equal to this is Java web app. So what is the difference guys? The difference is, so we can create the two manifest file. One is the pod manifest file and the service manifest file. In the pod manifest file, we need to provide the containers. In the service manifest file, we need to provide the type of the cluster and selector. The type of the cluster and selector. So cluster IP service, API version v1, kind service metadata name equal to spec cluster IP selector equal to app Java app. So this is the service manifest file. This is the pod manifest file. So get all the services, kubectl get svc, schedule a service using the manifest, kubectl apply -f. This is the service manifest file. Get svc. Note, in cluster IP, one virtual IP will be assigned for our service. Using that cluster IP, we can access service within the cluster only. This one also, cluster IP also within the service we can access. If you want to expose our service outside the cluster, we need to use the node port. Outside the cluster, we need to use node port, guys. So this is the cluster. Selector equal to type equal to cluster IP, selector equal to this one. So we want to use the node port. So we can use the node port also. So we can use the node port. Yeah. So the service file node port. Selector equal to which one, guys? App, Java, a web app. The selector is a, you see, guys, the selector is nothing but your label. So selector is nothing but your label. We need to provide the selector app equal to label, right? Yeah. So cluster IP, node port IP. So this is the node port IP. For node port, so enter question, guys. What is the range of node port in cluster IPs? The range is so 30,000 to 32,767. So what is the range of the node port, guys? The node port range is 30,000 to 32,767. So for the node port service, Kubernetes will assign a random port number. So we can access our service outside the cluster using the any cluster mission public IP without node port. Enable a node port using the security group. Security a group, guys. So you can use the load balancer also. So types of node ports are so cluster IP service and the node port service and the load balancer service. So we will explain this when we will discuss the auto scaling concept and external name load balancer concept, guys. Okay. So manually created pod is not recommended, guys. So in the above scenario, we have to create a pod using pod manually. So if we create a pod, then KTS will not provide high availability, right? So let's test it by deleting our pod, something like a kubectl delete pod name. So once pod got deleted, Kubernetes not creating another pod and application went down, guys, right? So that time we need to create the replication. If you want to achieve high availability, then we should not create pods manually. We need to use Kubernetes components to create a pods when Kubernetes will provide a high availability. High availability means always our application should be accessible. So what are the components, guys? Replication controller, replication set, daemon set, deployment, stateful set. So yeah. So what are the components? Replication set, guys. So replication set is nothing but if you set the replication, so when you delete the pod, it automatically creates, guys. It automatically creates. This is the beauty of the Kubernetes. What is that, guys? Replication set. So what is that, guys? A replication set, guys. So we'll discuss tomorrow what is the service port. So that services cluster IP, node port, and the load balancer, and I will discuss about the components of the replication set, guys. Okay, guys, understood? So what you guys can do, you guys can install the Kubernetes cluster EKS on AWS, guys. Okay, guys, understood?
Yeah, understood.
Okay, guys, please create EKS today, so and you guys can execute the commands, whatever the commands, right? You can create a simple manifest file and apply the kubectl and running the pod. Okay, guys, understood, Vinay?
Yeah, understood, Hari.
Understood,
Yeah.
1 second, guys.